Okay, so this lecture is about boundary conditions and the symbolic, what the symbols mean, what the boundary conditions is, and so on. So with the symbol, we have the reaction force, reaction force, and the boundary conditions, BCs. Like this. So if we have something that looks like this, or this, or just roller. This is called then a roller support. The reaction forces for this is only one force, upwards. And the boundary conditions for these are that y equals 0 and y double prime equals 0. This means that the moment is equal to 0. Okay. If we have a pin support like this, it's called pin. This one has the reaction forces like this, RA and RB. And the boundary conditions for this case is just that y equals 0 and y double prime equals 0. It's the same as the other one. And if we have a cantilever beam, it's called a fixed support. Fixed support. And the reaction forces for this case is RA, RB, and we have also a moment. So the boundary conditions for this case is that y equals 0 and y prime equals 0. So y prime is the angle equals to 0. Because the angle at the fixed support at A is then equal to 0. Okay. If we look at this, this is called a guided support. Guided support. And it has the reaction forces looking like this. RB and a moment. For this, we have the boundary conditions y triple prime equals 0 and y prime equals 0. This means that the shear force is equal to 0. This means that the angle is equal to 0. Okay. if we have kind of like a trivial case where there are no support, we call this a free end. And the reaction forces are obviously no reaction. However, the boundary conditions are y double prime equal to 0, and no moments, and also a no share. This means that moment is 0. This means that the share is 0. Okay. If we have a beam that has a spring on it at the end or start, we call this a spring support. The reaction forces for this is only RS, reaction spring. So the boundary conditions, this RS is equal to K times Y, where K equals the spring stiffness. Okay. And the last one is if we have a beam with something called rotational spring. We call this a rotational spring. It will have the reaction force like this, ms, just a moment. The boundary conditions for this is that ms is equal to r times y prime, where r equals the rotational spring stiffness. Spring stiffness. Okay, that's the boundary conditions you need to learn. Learn them by heart, because these come up quite a lot. Especially learn the boundary conditions for each case. It's very beneficial.